Hello everyone. Thank you for joining today's presentation. My name is Jody Scollard. I'm a business development manager with Chicago White Metal Casting. Today we're going to talk about high pressure die castings and their ever increasing use in the automotive electronics products. With the number of increasing amount of electronics in passenger cars and trucks, there is a much greater need for mechanical type systems that can dissipate heat, add structural integrity, and other factors that make high pressure die castings a very popular product and components for the automotive electronics. Just a little bit more about me before we get started. I've been with Chicago White Metal going on 14 years, a few years longer than that in the die casting industry. Prior to that, I spent 8 years with a large Tier 1 automotive supplier as a design engineer, designing new products, mostly for Chrysler and GM vehicles. If there are any questions at all during the presentation, please post them at the bottom of the YouTube screen. We will get back to you as soon as we can. There's some contact information here at sales@cwmtl.com and our phone number. Also, at the end of the presentation, there is some direct contact information for myself and a couple of others at CWM that you can contact at any time. Just a brief overview of the webinars that Chicago White Metal has published over the years. Since probably 2006, we've gone through and have done webinars for a wide range of topics for die castings, anything from Die Casting 101. We have some presentations about various alloys, magnesium, aluminum, zinc. We did webinars on each of those. We've looked at conversion from other processes, whether it be CNC machined or investment casting or other processes, over to high pressure die casting and what the advantages are of doing that. So all of these webinars are recorded and are on our website. So feel free to go to our website and search for webinars, and you should see all of these loaded that you could listen to. Also, if there's a topic that's not covered that you would like to have a webinar on, whether that's an individual session for your company, or if it's something that maybe we could do as for a larger audience, we'd be happy to look at that and look at doing a presentation specifically on that. We're always looking for new topics, so please don't hesitate to suggest something. So the agenda for today, we'll look at Chicago White Metal, our history, who we are. It'd be good to get an overview of us. We'll talk about whether or not a die casting is right for you. Maybe a different application or a different processing type is better for your application, and we'll talk about that. We'll look at the various die cast processes and alloy types. And then we'll get a little bit more into the specifics of the automotive electronic area and talk about why die castings are used, where they're used, and we talk about some case studies that Chicago White Metal has been working with in the automotive electronics area, and as well as some additional information and as I mentioned, contact information at the end. So the history of Chicago White Metal, we were started in 1937 in the Chicago area. You can see the progression on the screen here as we added different locations and expanded the location that we're in Bensenville, Illinois. And today we have just over 125,000 square feet of space in our Bensenville facility, and it's the third generation family ownership. So let's talk about whether a die casting is right for you. These are some of the bullet point items that we look at and consider when a new customer comes to us and says, hey, I've got this part. Is the die casting the right thing? Should we be looking at something else? And so these are a few of the things that we look at to take all that into account. Project volume is obviously a big one. Is the volume right for high pressure die casting? Is it too low for high pressure die casting and should be something else? So that's a big factor. Part size, obviously, does it fit our equipment size, which we talk about in a little bit about what our size range is, but does the overall part size fit with us? We look at tolerances and the various features that are on the die casting. We try to ask as much as we can about the overall application, what type of physical properties are needed, mechanical properties, environment. Is this going to be an outside product? Is it going to be inside? Does it need a high level of corrosion protection? We try to look at all of those and take into account as early as we can with the customer, so we can, one, pinpoint whether high pressure die casting is the right process, and two, to see if we can offer suggestions that might help save the customer money, whether it be combining parts into a single die cast part, add or remove features to make it easier for us to produce or a die caster to produce. Anyway, the number of those things go into account, and we try to work on that as much as we can up front. So our strengths at Chicago White Metal, it starts with our engineering and technical experience. As I mentioned, one of the things we love doing is getting in early with a customer on their new application, talk about the project, see what we can do to help facilitate the design and other product phases to see if we can reduce cost and help the customer in different ways. Chicago White Metal is very financially stable. We have zero debt, which in these days and times is an important factor when looking for a partner die caster to partner with. We have the ability to cast all three main alloy types for die casting: aluminum, magnesium, and zinc. We do all of those under the same roof, which is fairly uncommon in the die casting world. And what that allows us to do is, when we look at a new application, we can look at it fairly unbiasedly. If it's something that's fit better for magnesium than aluminum, we're going to tell you, because we can make both. So it doesn't matter to us which alloy type it fits into. It's whatever is better for the application. The value-added processes that we have outside of die casting, so the engineering services I talked about, very highly technical, experienced group of engineers we have. We also have in-house CNC and conventional machining. We also have in-house mechanical assembly. So if there's some mechanical parts that make sense to come in and on a die casting, and you'd rather have it come in as a subassembly, we can certainly assist with that. And then we apply various surface treatments and different finishes to die castings. All of those are done with local outside partners, but we have been doing this for decades and decades, and we've got sources that can handle pretty much any finish that you need on a part. So dig a little more into the value-added type of things. I mentioned engineering, the machining that we do. We've got 32 odd, around 32, I believe, CNC machines of various sizes, so we can handle a very wide range of machining. The surface treatments I talked about. Also things like if a customer wants an entire product given to them, so we can take a number of components and kit them together in different packaging types and provide that. We also, for some of the products that our customers need, they need to be leak free, so we have the ability to do pressure decay leak testing that we've set up in different cells. We can also do x-ray of parts if a customer needs, as well as a number of custom gauging applications that we're able to set up. So let's look at the die casting process specifically and the various alloys that are with it. So this first animation is looking at the hot chamber die casting process. So there's two types of processes that we'll talk about: hot chamber and cold chamber. Hot chamber, when you hear that, you're basically talking about zinc and magnesium. And as you see on the right of the animation, you can see the boiling molten metal inside the furnace. Plunger comes down, extracts a given amount of material, pushes it into the die. The part is solidified and formed, and then you can see the ejector come out and press the part down onto a conveyor. And then the die is sprayed with lube, closes, and then the process starts over. So fairly straightforward. Metal comes in a fraction of a second, the part solidifies, part drops off, and then is processed down the line. The other process is cold chamber. And when you think of cold chamber, typically that's aluminum. Also, larger magnesium parts can be produced in cold chamber processes. The difference is on the right of the animation, you'll see the metal, instead of being injected in via gooseneck, it has a ladle that picks up a predetermined amount of liquid from a cylinder, and then puts it into the die, is injected in, and the rest of the process is very similar. But the difference between hot and cold chamber is how the metal is introduced into the die. In hot chamber, the injection systems are actually physically inside the molten metal. In aluminum, in cold chamber, the melted aluminum is in a separate cylinder, and a ladle comes in, scoops up a measured amount, and then puts it into the shot sleeve. Basically the same, but just a little bit different on how the metal is introduced. So when we talk about the various die-cast alloys, aluminum is sort of the go-to. It's where most people will typically start. Provides the best overall value of properties and economics. And then we usually will take a look at the application and what's required, and maybe move to a different alloy. So magnesium, if it's something that's going to be in a very weight-sensitive application, you need very, very light weight, then we'll typically suggest that a customer look at magnesium. And that's what we're going to talk about mostly in our conversation today about the electronics. Or we'll go to zinc. Zinc is a heavy alloy. It's about 2.5 times heavier than aluminum. But there are certainly some advantages of zinc. You can do thinner walls, less draft. Tool life is much, much better in zinc than the other two alloy types. So especially if it's a small part, many times we'll really take a hard look at zinc and see if it's a good option, because it does offer a lot of advantages. And unfortunately, designers these days don't think about zinc too much when they're looking at die-cast alloys, and it's a shame, because it's a great alloy. If we look at the alloy comparison, and this is a Chicago white metal specific chart, so these sizes and size ranges we can produce are specific to us. They obviously can get much, much larger with other companies, but this is where this is the arena that we play in. So for aluminum, we can go up to about 10 pounds, say a footprint of 18 inches by 18 inches, maybe a slightly bigger than that, depending on the geometry of the part. Magnesium, the footprint is about the same, but obviously the weight would be much less, because it's much lighter weight. So we can do maybe up to a 6-pound shot with magnesium. Zinc, we can do, again, similar type of footprint from a length and width standpoint, and that'll get you about an 8-pound part potentially. And then we have the ability to do miniature zinc. That is a kind of a subset of zinc die casting, high pressure die casting. Miniature zinc are run in very, very small, low tonnage machines that run very, very quickly. If you ever see a video of a miniature zinc machine running, it looks like popcorn coming out. It's cycling so fast sometimes. But for very, very small parts and typically higher volume parts, the miniature zinc process is fantastic. It offers a wide range of alloys, and it's something that we would highly suggest if the part size is right. So now let's get into more specific about the automotive electronic components and why die casting is a good advantage for some of the products. And it obviously starts with weight. Trying to get lighter in the automotive world has been around for a number of years. That's not surprising. Anything you can do to reduce weight helps fuel economy, helps reduce emissions. A lighter weight car typically is better handling. Also some increased safety measures in there with getting lighter weight. Also, die castings are 100% recyclable. So that is a bigger and bigger factor that people are looking at when specifying which types of alloys and which type of products you're gonna produce. Die castings are 100% recyclable, and especially compared to plastics. Even though people think plastics are highly recyclable, if you start looking at the actual recycling stream and process for plastics, you might be surprised of how incorrect that is, or how problematic it becomes to recycle plastic. So high pressure die cast parts are highly recyclable and a good advantage. The other big factor for that die castings provide are EMI, or electromagnetic interference, when compared to plastics. Obviously, when you have a electronics enclosure, you have a number of electronic components inside. You want them to be protected from any type of interference, EMI, RFI, and die castings inherently do that, versus plastics, where you may have to put a different type of coating on a plastic part to achieve that protection. Die castings, that is an inherent quality, so that can be a big advantage. Mechanical properties also are very good, and as well as thermal conductivity. Obviously, you've got electronics, you've got heat that's being generated, and you want to get that heat out. And die castings have excellent thermal conductivity properties, especially when compared to plastics. So that's a big advantage. Just looking at the different areas where die castings are physically in a car, it runs from head to tail. So it's large things, large structural parts, mostly aluminum and magnesium for the large structural components. Zinc is used in many applications. Typically, again, small parts. You want to. Zinc is heavy, so you want to keep it keep the weight down. But say turn signal components, door lock mechanisms, seatbelt components, even the highly cosmetic emblems that are sometimes in the floor mats of vehicles, those are zinc parts. We make some of those. And so zinc is used heavily, but again, typically in the smaller parts. A lot of different motors that are used in vehicles these days. You actually would be surprised at how many motors are in a vehicle to move seats, and to move mirrors, and to move retractable foot pedestals. You'd be surprised. So a lot of different motors. Most of those motors have a motor housing that's a die casting. Again, a little bit of structural stability, as well as heat dissipation to get the heat out of those motors. And then we'll talk about some of the electronics sections, products that are in vehicles. We're going to dive a little bit more into that. So when you look at the specifically in electronics, whether it be different types of sensors, there's various types of drivetrain electronics that we'll talk about a little bit. Autonomous vehicle electronics are becoming a bigger and bigger thing. Again, all of these generate heat. All of these need to be somewhat structural components. All of them need to have some sort of protection from RFI, EMI interference for the electronics. And die casting, again, die cast parts will inherently do that. So it's a fantastic thing to consider if you're designing an electronic component. And we talked about this, and we've talked about this several times. So again, number of different components. Trying to think of some different applications. We'll talk about it a little bit more as we get into each case study here. So let's look at some of the case studies that Chicago White Metal is currently working on, or has in the recent past. So the first one is a electronics housing for an electric vehicle. This is a fairly large part, maybe 3 pounds. It's an aluminum die casting. The main objective here was needed to be a leak-free product. The requirements for this was water intrusion inside the enclosure. Very tight tolerances on some of the as cast and machine features, so that was important. So this part, fairly high volume. This was say 25,000 plus per year quantities. So it made the most sense as a die casting. It would be very expensive to try to do this as a CNC hog out part, for example, or if you looked at it as an investment casting. Again, that would be very expensive at those types of volumes. So the manufacturing process that this part sees is die cast and die trim. It has both CNC and conventional machining. So there's some features in there that we do in a CNC. There's other features that we do in a conventional drill tap reaming station. So those are both incorporated. The part then gets vibratory deburred. We do a little bit of assembly onto this part. You can see the little nub at the front of the product that gets pressed in. The part then gets impregnated, so we go out for a resin impregnation that helps fill any micro voids that are in the casting to help with the leak-free requirement. And then the part is 100% pressure decay leak tested. So we put it in a fixture, inject it with air, and then measure the amount of air escaping. So it's done on a 100% basis. And confirms that when we ship a part out that the customer can expect a leak-free part. The next product is a smaller electronic enclosure unit. The requirements for this one was to make, again, this is high volume, say 100,000 plus, very tight tolerances on some features. Again, another aluminum part. Flash requirements were very tight on this. Obviously, anything that's got electronics around it, you don't want loose flash interfering with the electronics. So that was a very specific requirement from the customer to be completely flash free. Excuse me. So the manufacturing process here was die cast, die trim, and deburr. We were able to do the trimming operation in such a way that really limited the amount of potential flash that was going to be in the part after casting. We were able to do a number of different areas as cast. In discussion with the customer, there was ways we could modify the design slightly to do some features as cast versus machining them, which is how it was originally intended. So that saved the customer money. And again, that's a big objective of ours when we look at this with a new customer. What can we do to help the overall product? You want to get your most bang for the buck with a die casting, so let's look at it as early as we can to help that goal. This next product is a support structure. It's a mount for a rear view mirror. As you can see, the die casting on the right there. Pretty tough little part, actually. Very highly high toleranced areas of this part. This is a magnesium part, so very lightweight, still good structural stability. Again, the challenge is very tight tolerances, and the cosmetics were actually very critical for this. And in this product, we were able to use a bit of a novel approach to degating the part. We were able to do that in the die, so it's kind of a two-stage ejection system that allowed the die-cast die to separate from the gates and overflows during the main cycle. So that's a bit of a novel approach to doing this, but it was able to save some money, save some cycle time, and that was a big advantage for our end customer. So in result, good reduction in part price because of that ejection system, and we were able to maintain the different tolerances that were required. Next product is a headlamp ballast. So this is part of an assembly. You can see the ballast assembly chart there. So this is a very high volume product, couple of million pieces type of number. So it's very high volume. This is another magnesium part. Again, another leak-free requirement for this part. So the manufacturing process is die cast, die trim, gets vibratory deburred, and then gets pressure tested. Again, 100%. So great little part. This part maybe is say 3 inches by 3 inches. So you can kind of tell the scale on the screen there. These type of lamp assemblies are used in pretty much every car out there. So there's a number of different variations to this, but again, very, very high volume. Needs to have some heat dissipation qualities. So that's why, again, magnesium die cast was selected. This is a transmission control module, and this is a great example of where designers right now for OEMs are looking at ways to eliminate mechanical parts, and this is for this part we're looking at here is part of a shift-by-wire system. So this is a control module that takes the input when you take your transmission lever, change gears. That instead of having linkages and wires and other mechanical type of components, there's sensors in there that relay that to electronics, and then that is relayed to the transmission and say, hey, I need to shift gears. So there's a lot of that going on right now, whether it be transmissions or brakes. Brake-by-wires, another big thing that's out there. So there's a number of these systems that have historically needed a number of different mechanical linkages and wires and other parts that the customers can now do away with and just use sensors and actuators and different types of more electronic type systems. So all of that needs some mechanical components in there still. They need heat dissipation for the electronics. They need RFI, EMI shielding that we've talked about over and over. So again, another great advantage of die castings in these applications. This is an aluminum part. Processes die cast, die trim, vibe deburr, gets some amount of machining, and then again it gets a pressure test. So many of these electronic systems, as you can tell, don't like any kind of water or any liquids getting inside the various packages. So they need it to be pressure tight. The last product we're going to look at is a disconnect for a front stabilizer bar for Jeep. So this is more of a structural part, not so much electronics, but it's a good another good example of where die casting can be used and being a big advantage. Objective here was have some rigidity, ability to withstand an impact strength, and again be watertight. Since this is usually underneath the vehicle and is exposed to a lot of elements. Aluminum part. Manufacturing process is fairly simple here: die cast, die trim, and then deburr. We were able to work with the customer to come up with ways to reduce the amount of machining, or actually to no machining on the part, so all the tolerances and features can be held as cast, as well as being talking with the customer to use rivets or self-tapping screws rather than having to do a secondary operation of drilling, tapping. We were able to get away with that. So again, a good opportunity to get some cost out by working with the customer up front. If you'd like any more additional information, please visit the Chicago White Metal Design Center. You can see the website there, www.cwmdiecast.com. This used to be a section where we required a subscription and people to log into. We no longer require that. It's now free to anybody who wants to go take a look at it. It's an enormous amount of information about die casting, and I invite you to go on and search around. If there's something you can't find, please don't hesitate to contact us, and we will get you the information that you're looking for. Here's some contact information that I mentioned at the beginning. John Miller is our VP of Sales and Marketing. Mike Dimitrov is our inside sales manager, and then me down at the bottom there. So those are our direct emails. Feel free to take those down. Give us a shout if you've got any questions or have an application you'd like to run by us and see if it's something that would be a good fit for both us and you and as a die casting. Well, again, thank you very much for joining today and watching the presentation. Chicago White Metal loves working with die castings. We love talking to customers about their new application. And again, we take pride in the fact that if it's not a good fit for a die casting, we will help you find the right process that fits your part. So don't ever hesitate to come ask. We'll give you an honest opinion of of how it looks, and we'll help you as much as we can get the part to an ideal die cast solution for you. So thank you very much, and we look forward to hearing from you.